Hey everyone, it's Mrs. Olson. Welcome back to Algebra 2, second semester. Unit 6 is polynomials. Polynomials will be defined with Mrs. Yamasaki in the next lesson. Today we're going to be reviewing properties of exponents or rules of exponents. Before you get started, make sure you've printed out this document. If you're not able to print it, do look at it and set up your paper appropriately. Make sure your name is on your paper, the unit and lesson, the title of the lesson. Also, in parentheses here, you see this 5.1. It means that this lesson is in chapter 5 in your textbook, lesson 1. So if you want to look there for any more examples, you can, or some further explanation. I'm going to try to go through these properties quickly here and then let you work on the examples. The next video goes over the examples and also scientific notation. Here we go, product of powers. Let's review an idea. This is a power overall. Sometimes just the exponent is called a power, but in general, this is a power. The bottom number or variable is the base, and then the number up to the side, or it could be a variable as well, is the exponent. Now we're doing a product of powers. Product means that you're multiplying two things together. And this rule in particular only works if the bases are the same. So we have two x's there. In order to do this problem, you would add the two exponents, m plus n. In this example, x to the third times x to the second, again, because the bases are the same, I would just add the exponents. I'm going to quickly just show that that works. X to the third, x squared would be like that. And overall, you're multiplying 5 of those, right? Power of a power. So again, this is a power here, and there's another power there. This rule, you multiply the two exponents together. So it'll be x to the m times n. In this example, this would be x to the 6th. The reason this works, x to the third times x to the third would be the same thing as x to the third squared. And then using our previous rule, you would add the exponents, making it x to the 6th. Number 3, power of a product. So inside the parentheses, we have multiplication happening. No other operation. This does not work if addition or subtraction is happening here. This only works if you're multiplying different numbers and variables together. There can be numbers in here as well, but it has to be multiplication. Basically, what this is saying is that this power will distribute to all the things inside the parentheses. So x to the m and y to the m. For this example, x, y to the third would be x to the third, y to the third. Again, showing why this works. This is really what this is asking you to do, xy times itself 3 times. But you can reorder multiplication. And then when you reorder it, you can see that you could rewrite it as x to the third and y to the third. All right, so I'm going to go out of order here. I'm going to do number 5 before I do number 4, because I'm going to use number 5 to show why 4 works. Quotient of powers. A quotient means that you're dividing. And again, like the very first rule, this has to be the same base for this to work. This does not work if these are not the same base. The rule is if you are dividing with the same base, you subtract the exponents. In this example, if I use that rule, this would be x to the second. And you do subtract the exponent that's in the denominator from the one that's in the numerator. The reason this works, imagine if I wrote out x to the 5th like this, with 5 of them there, almost wrote a 5 there, and 3 in the denominator. Every x in the numerator cancels out with 1 in the denominator, leaving 2 in the numerator. All right, so using that property, I will show why this one works. But the property is if you have x to the 0, any number variable to the 0 would be equal to 1. So using this idea here, If I subtract these exponents, right, the bases are the same, I would have x to the 0, 3 minus 3. If I wrote it out like I did in other examples, what does x to the third mean? It really means this. But something over itself is just 1, right? These all cancel. You just get 1. So these two problems, which are the same problem, you get these two different answers, but they must be equal because we started with the same problem. So something to the 0 power is 1. Power of a quotient. So this time we're taking a fraction, a quotient, a division problem, and we're taking all of that to a power. This is similar to the one above it, the power of a product where it distributed. The same idea here. This power will distribute to the numerator and denominator and everything there, like that. So in my example, x over y to the third will become x to the third over y to the third. And I'm going to skip showing why that works for now, for time. Negative exponent. So this one is usually the most confusing for students. So I will explain it, but x to the negative n, basically you're going to make that a positive exponent, but you're going to move it to the numerator, excuse me, the denominator. It's in the numerator now, and you're going to move it to the denominator. So for this example, x to the negative third, that would become 1 over x to the positive third. All right, so let me show you why that works. Let's use an example. Say I had x squared over x to the fifth. That would be x over x, x times x over 5x's, like that. Now, using our previous rule, right, where we cancel those out, I'd get 1 over x to the third. And as I was starting to say, using our previous rule, we would subtract those, and that would give us x to the negative third. So doing this two different ways, doing the same problem twice, we can see that x to the negative third is the same thing as 1 over x to the positive third. So the next two are just variations using these different rules. What if it was in the denominator? What if the negative exponent was there in the denominator? Well, in the same way, you would move it and make it positive. So this is going to be moved to the numerator and become a positive exponent. You could write that over 1, but you don't have to. So in this example, this would become x squared. All right, so we're going to combine some rules here. What if you had a quotient to a negative exponent? The final answer, the y here, would move to the numerator, to the n power, and the x would be in the denominator, to the n power. So let me show you why that works. First of all, that negative 2 will distribute to both the numerator and denominator. But using previous rules here, we know that that'll move, become positive. This will move and become positive, like that. There you go. So you're going to use these rules to simplify the next set of problems. Go ahead, you can stop the video and try these 5 problems. When you have an answer with a negative exponent, try to make your final answer with a positive exponent using those final rules there. Anytime you have a negative exponent, move it so that it becomes positive.